Welcome to this week's programming tips. First, we're going to look at debugging and fix some more broken code. Then, for programming style, we're going to simplify some conditional statements. And then third, we're going to revisit input fields and see how we can enter in numbers as well as strings. So you've learned about global versus local variables now. Let's look at a couple of the problems that arise using them. Okay, here we have a global variable n. A function that increments it. We use it 3 times, so we should end up with the value 3. But we get an error that says local variable n is referenced before assignment. But we don't want n to be local. We want it to be a global. Problem is, we didn't tell Python that. So that's what we need to do. Anytime that you are assigning to a global variable within a function, you need to tell that function that the variable is actually global. As such, and now it works. For this example, we once again have a global variable n. We have a function that's going to assign some value to n, just whatever's passed to it. We call that function a few times, and we print out the resulting n. Well, what we want is that n at the end has the value 7, because that's the last thing we assign to it. What we actually get is 0. Why is that? So in our function here, what happens is we pass in 2. Well, we didn't tell it that n is a global, so it creates a local variable n, assigns that to have the value 2. The function ends, so it gets rid of that local variable. We call it with the value 15. We create another local variable n, assign it the value 15. The function ends, we get rid of the local variable. We do the same thing with the value 7, and we've never ever changed the global variable, which still has the value 0. So all we do is change the code to actually tell the function that the n should be global, and it works. But notice the difference from the previous example. In this example, we weren't actually we weren't referencing or looking at the value of n before we were assigning to it. Okay, when you do, it gives you an error because, well, you haven't created the local variable yet. When you don't, it says, okay, I'll just assume it's a local variable and go on my merry way, which in this case gave us the wrong result. All right, for our next example, it'll be kind of similar. We once again have a global variable n. We have a decrement function that's going to decrement n by 1. We have actually declared n to be global, and then we decrement it and print out the result. We're also printing out the result of the decrement function. Okay, n is -1. Okay, what we would expect. But what the heck is this none that x has? I mean, what? What's going on here? Okay, note, in the decrement function, we're not returning anything. So why the heck are we assigning a variable to the result? We're not returning anything. And what the heck is this none? Well, the problem is, since we don't return anything in this function, well, Python says you always return something from a function. In particular, if you don't return anything explicitly, then the value that is returned from it implicitly is this weird value none. What is none? Well, it's really nothing, okay? Meaning that it's not really good for anything. You don't ever use it for anything, and it only appears as a placeholder so that we can say that every function returns something. So if you ever see it like this, that means that you shouldn't have assigned like this, or you should have actually returned something. So you're now writing interactive programs, and you're going to be writing larger and larger programs in this course. Okay? So as you do so, it's generally going to become harder to debug and understand what's going on in your code. Okay? So I want to introduce one very simple technique to help you. To illustrate, I'm going to run this code I haven't even looked at it yet, and I want to see if I can figure out what it's doing. Okay, I'm going to enter in a number, get the value 1 back. Okay, I'll increment a couple times and enter in 3 again. Get the value 9. Let's enter in another number, 6. I get back 36. I'll increment a few more times and put in the value 18. Get back the value, big value. Do you know what's going on? Well, it's not really clear. What's the problem? We don't have enough information. So how do we get some more information? Here's the technique. We're going to just add print statements to get more information of what's happening. Now specifically, we're going to print out the inputs and outputs of each function. Okay. So here, in F, I'll just say, well, n is an input, but also x is acting like an input. It's a global variable that is used in this, so I'll print it out. And then I'm also going to print out the result of this function. Down here in button handler, it doesn't have any inputs, but once again, x, the global variable, is acting like an input and an output here, since we're updating it. So I'll print that out. And as I do so, note that I'm also labeling everything because there's a potential to get a lot of information printed out here. So we want to label it to make sure that it's all reasonably understandable. Here in input handler, we have just an input. So I'll just print out the input and without any results. Okay, and I'll rerun. And let's see if we can understand this code better. Okay, I'll enter 3 in. Okay, the input handler inputs 3. Then it calls this function f, which, given 3 and 0, results in 1. Well, if you look at the code here, well, why? Because it's taking 3 to the 0th power, which is 1. Okay. So I'll hit increment a couple times, and you see each time you are incrementing the global variable, okay, in the button handler. Okay. Now let's enter in 3 again. Well, the input is 3, and now it's calling calling f on 3 and 2. Why 2? Because that's the last value of x here. Okay. Well, 3 to the 2nd power is 9. Okay. And I can increment a few more times. You can see that button handler is incremented 3 times. I can put in a bigger number like 6 and enter that. And what is it doing? It's taking 6 to the 5th result, okay, which happens to be 7776, and prints that out. Okay, so by printing out more information, we can understand what's going on in this code, and now we can make a decision of, is that actually what I wanted to do or not? Okay, but the underlying idea here is it's very useful to use print statements while debugging to print out the values and label the values so you know what actually you're printing out. Now let's turn to an issue of code style. I often see novices writing overly complicated conditional statements, so let's see if we can simplify those. So here, consider this example, okay? It takes two inputs, both of which are Booleans, and it's going to return another Boolean in this case. The documentation string says returns true exactly when A is false and B is true. Let's verify that that actually is the case. So notice here that I'm testing all 4 possible cases and the documentation string is correct, but it really is just documenting, it just echoes the code. It's not very useful. So, well, let's first consider B equals true, just this one part here. Okay? How can we simplify that part? So when B is true, B equals true is true. When B is false, B equals true is false. So simpler is just to say B. That's the same thing. Now similarly, when A is true, A equals false is false. When A is false, A equals false is true. All we want to do is negate A here. Okay? So I'll change that to not A. Let's make sure that those simplifications haven't changed the meaning of the program. Okay, I'll run it again, and I get the same output. Good. Next. Okay, if this condition is true, then I return true. If that condition is false, then I'm going to return false. Why not just return the condition? That's a lot simpler. Let's get rid of the conditional entirely and change this to like that. Let's see if I get the same output. I do. Good. Let's consider one more example here. Okay. Similarly, okay, we can simplify this conditional a little bit. We already know that. What is this function supposed to output? Okay, as the documentation string says, it returns false exactly when both the inputs are true. Okay, so we want to make sure we keep that the same. Now, if this condition is true, then we return false. If this condition is false, then we return true. Well, in other words, we just want to negate the condition. So let's get rid of the conditional again in this example and just say that we want to return the negation, or in other words, not what we had. Let's see if that's the same thing. Run that again, and it is. Okay, so you can simplify a conditional in multiple steps in multiple ways to produce much more understandable code. Okay, the next step really ought to be to rewrite the documentation string to, have a better description of what this is actually doing. Also, on the matter of code style, the link that we just provided goes to this page describing the standard Python conventions for style. Most of this, is pretty straightforward. We've described some of the ideas already, having comments, documentation strings, and good variable names. Additionally, some of the other main ideas include having blank lines between definitions and spaces within expressions to make them more readable. Admittedly, our code doesn't always follow these conventions, but we should, and so should you. Lastly, let's return to this example. Okay, so we used an input handler. Remember that an input handler always gives you a string. The argument is a string. Well, what if you want to use a number? Okay, well, here's how we did it in this code. I used the function float. Okay, so let's just turn to the documentation here. And we go to CodeSculptor Python. Okay, we have a function here, float, that given a string will give you back the corresponding floating point number. And similarly, there's a function called int that given a string that contains an integer will give you back an integer. Given that floating point and integer numbers are basically the same thing in CodeSculptor, it's safer just to use float whenever you're converting a string to a number. Okay, simple enough.